Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Rowell and François.
Hey everybody, thank you for listening to this brand new episode. Just wanted to give you a short introduction. This was a webinar that François and I did together in Canada, in London, Ontario, where we talk about Wi-Fi design, and we went through a set of Q&A questions that have been given to us through a survey we asked you guys to fill out. So I hope you guys find value in this webinar. This is the audio only version. If you want to see the video, you can head over to the show notes where you should be able to find that on YouTube. So I hope you guys enjoy this, and apologize for some of the mistakes we make in this webinar. It's our first time doing it. And I'll also apologize for the audio quality, but I still hope you guys find it valuable. So here we go.
Are we recording?
Yeah, we're good. So we can start. So I don't know if, thanks Chris, two Chris's for joining us. Let us know where you guys are joining us from. And then we have a caller.
His name is 1309 ***657.
and making a change to production. So
perfect company.
We'll just be in the back.
Reboot.
I always make a joke at work with new guys. It's like, okay, on command line, just do right erase and then reload.
And then when they ask you, are you sure? Just say yes.
And then fix it. All right, you can fix that right there. All right, so we're going to talk about Wi-Fi design. We did a questionnaire a couple weeks back. We've had it open for a while. So we took a lot of those questions and put them here into this slide. And Chris says, I think he's calling in from Ohio. Is that what, OH? Or he's just saying, oh, Ohio. Welcome, Chris King. And so we're going to go through this Q&A. And then if you guys have questions, feel free to put it in the chat. And we'll start going through some of the questions we got initially. And then we'll have a slide to open it up for any other questions. Yeah. Anything else?
No, that's perfect. So we want this to be interactive and as much as possible. So if you have questions, feel free to send them over, and then we'll just answer them.
So if you guys don't know who we are, because I know we had a lot of new people sign up for this. My name is Rowell. I'm from California, and I actually just flew in this morning to Toronto. I think I got in around midnight and then went to bed at 2.
Oh my.
2 a.m. Then I woke up and drove here. And yeah, the traffic's pretty bad out here in Toronto.
Yeah, it's pretty dense urban city.
So I'm a network engineer for higher education. I also do consulting in the Bay Area and sometimes in different states.
And you also prepared all the slides. I just want to say that. I didn't have anything to do with the slides, so thank you, Rowell. Amazing job. My name is François, so I live here in Canada. Rowell came all the way just to see me, I guess.
Just to visit.
And so I have my own Wi-Fi company. It's called Symphio Networks, and just work as a Wi-Fi engineer, working on different projects. And also I co-host the Clear Send podcast. You forgot to say that.
Yeah. Just in case you guys didn't know, we do a podcast. I'm sure. All right.
All right.
So just want to touch upon the importance of doing Wi-Fi design, and because I do run into a lot of people who go, why should we do it? I mean, you just put APs up and you're done, right? But I will say maybe for some very small environments, maybe that's true, where if you've got maybe just 1 or 2 access points, you can kind of put them in. Yeah, you can kind of just estimate where that's going to go. But when you're dealing with enterprise or warehouse, really complicated environments, distributed environments, and other scenarios where maybe RF isn't going to be optimal if you just place them randomly, So that's why we like to focus on design, is for the long run, to make that a better wireless network for the people that use it, whether that's like low latency type applications like these, right? Like these, you're going to have multiple people doing these Zoom meetings, right? And an office space with multiple meeting rooms. Sometimes, I don't know if you guys notice, in a meeting, everyone likes to open up Zoom, even though they're in the meeting, and then they join the session and they're watching the video, but they're there in the meeting. So run into a lot of those. How about you, François?
Yeah, so you related to what you said, like designing Wi-Fi for us is more like planning the network, right? Mm-hmm. And making sure that all the installation, like all the equipment that we install and we configure will be configured properly to support the client and applications we'll have. And what happens if you don't do that work, especially in the enterprise environment, is that you would think it would work for certain scenarios, but at one point it's going to break. And then if you didn't do proper planning, it's going to be hard to troubleshoot. And I've worked with multiple customers, where they're just calling me to troubleshoot Wi-Fi, and they've been having Wi-Fi issues since they installed the new Wi-Fi, right? Yeah. And then it's been 1 year, sometimes it's 2 years, and then they call people, no one can fix the Wi-Fi, and then you come in, and it's like simple for us, I guess. Like it would be simple fixes, channel assigning, channel width, maybe changing a couple of AP locations, wrong type of antenna, and then all of these, small things could have been fixed by a proper design, and they would have been saving a lot of money. So maybe it's going to cost a little bit, upfront to do a proper design, but believe me, it's going to save you a lot of money in the long run when you think about the overall cost of a Wi-Fi network maintenance and operation. Something else I want to mention as well is what it's really important to keep in mind what drives your Wi-Fi design. And what drives your Wi-Fi design is the client devices you have and the application you use. And those two will evolve over time. So you have to keep that in mind as you bring more devices, newer devices, newer applications. Try to identify which ones are critical for your business and try to see if you have to adjust your Wi-Fi design. Sometimes you have to.
Yeah. So it's going to be this life cycle of where you do a design, then you optimize it after you initially deploy, and then you're going to have this period of where you're just going to use it, and then things will change, and then you kind of start that process all over again as scenarios change, new devices come in, or things like 802.11ax coming out. You're gonna have to change the way you do design there, and so we'll kind of touch upon
talking about AX. I think you have a quote for that.
Talking about an AX, 802.11ax. This is my favorite quote when I really like to tell people about design, right? It's because it's an Abraham Lincoln quote. It's, "Give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe." Because you want to plan, you want to do a lot of that, asking questions. And then when you do the configuration of the design, it's actually going to be fairly quick a lot of the time, because if you've gathered a lot of the information that you're supposed to gather, like the requirements, the floor plans, the correct floor plans too. Yeah. Like you're not going to spend as much time doing that part. You'll kind of breeze through designing and configuration because you've done all the planning up front.
And plus you have something you can go back to in case you have issues or in case you need to change it. You have, everything documented. You can go back into, you can tweak it when your boss or business unit has a question. Can I install, new connected product in the student dorm room, for instance? You can go back to it and see if it's going to work or see if you need to adjust anything. All right, let's get into it. Let's start to answer questions.
Yep. So we'll start off with the first question.
Yes. Sure.
This is a common one. What software do you use for heat mapping?
My finger and my.
Your finger? I, on the other hand, I like to use Ekahau. That's my primary Wi-Fi design tool. It's also good for troubleshooting and validating. And this is actually a screenshot of something I did. That's a 5 gigahertz heat map, just in case you're looking at that. The gray area.
I noticed my office here is not properly covered. I use Ekahau as well.
We use the Sidekick. We also have the Sidekick that we use with our software. And I like Ekahau because I use a Mac, so it's primarily on the Mac. when we're designing, and then you use a sidekick. And a lot of times too, we could use the iPad.
Yes.
For design, so I don't have to hold the laptop.
Yeah. The new Connect solution is awesome. Like with the sidekick, the iPad is very convenient, and when you try it once, you're like I'm never going to come back to a laptop to do my surveys. And then for the planning, so that's more for the site survey, but for the design, they also have their own planning tool inside Ekahau. And myself, I'm a teacher for the Ekahau design class. So that's what I use to do my design, and I use Mac as well. So it's easy, and it's a very solid solution. Mm-hmm. It does have some limitation. Maybe we'll talk about that, but no tool is perfect. Yeah. But for what we do, it's very solid. And then if you do your due diligence and you gather the proper requirements, the design that Ekahau will give you would be solid, and that's something you can rely on if you do it properly. Yep. If you don't know how to do it properly, you can just go to the ECSE design class.
Yeah, and then, I highly recommend the class. It was really good. It's a good refresher, and there are people who aren't professionals in Wi-Fi, so they'll ask a lot of questions, and it's kind of good to hear what those people are thinking about. Yeah. But Ekahau is also not the only Wi-Fi design software. There's also IBWave, which does a lot of and they're big in the cellular world too, but they also have a Wi-Fi design application. And what's nice is they do a lot of the 3D heat mapping. They also take things like reflection and diffraction into consideration. So that's another great application.
So one of the limitations of Ekahau is that it doesn't take some of the RF behaviors into account to do the modeling. So like you said, reflection, refraction, inclination floors, all these, advanced RF, calculations are not really taken into account in Ekahau. And when you start designing with directional antennas, changing the orientation of the antenna, that starts to matter quite a bit. So IBWave is really good for that, because it will take all of this into consideration, and you can really see that it's going to affect the RF propagation in your environment.
They'll also do a bill of materials. So if you list all your access points, even down to like the switches that they're connecting to, you can even do the sample cable runs, so you can see what your distances are going to look like. Yeah. And that'll put it all into a bill of materials, and that's kind of neat, because then you can kind of give that to your salesperson or the partner that you're working with, and then go, here's what I need for that. And also they have a 3D viewer that you could send to a customer, and then be like, here, Mr. Customer, this is your predictive model, and they'll be able to see in 3D. They could actually move it around and kind of see, like, from the person's point of view standing there, what does the signal look like?
In terms of cost, we didn't talk about that. These are not cheap. So these are like enterprise software, so you have to pay quite a lot of money to use them. If you don't have a lot of money, I guess, there are also alternative solutions out there. When I started my business, I used Tamograph, which is a site survey software as well from Tamosoft, and it was a little bit cheaper. I think I paid maybe 1,000 USD for it, and then it does the planning. It does a pretty good job at it. It's not as evolved as Ekahau and IBWave, but you can get some work done with it as well.
Yeah, I think some of the pros and cons for different, the on the more expensive side versus the more cost effective side is you're gonna have less support, less updates. The algorithms are a little bit different. Like the features will be a little bit different. So it'll be less features, but you could still at least start a design.
And also, I don't know about you, Rowell, but I don't like to rely on the vendor RF planning tools to do my design. The one where we just put a focal plan, place an AP, and then give you a circle.
A perfect circle.
Right? So I don't really trust these planning tools. I call them the sales tools, like they're just designed to sell APs.
Yeah. Wi-Fi signal is not a perfect circle. So if you start seeing that on your heat maps, then it's not the best heat mapping tool.
All right. You want to move on?
Yeah. All right. So one of the questions we got was, how do you decide if the coverage area is high density?
Yeah. So that's a good one. And to decide, so what I do is I look at the client devices, the number and type of client devices I'm expecting in this area. And also I'm looking at the amount of traffic they'll be generating. So that's not something I just, I don't have like a threshold, right? I have a threshold when I have no idea what type of devices and client device and application I'm expecting. But if you know exactly what type of application devices you're expecting, you can do proper capacity planning. And I think we have more questions about that.
Yeah.
So we'll
this one's like specific to high density. And the screenshot I have here is of Cisco Live, which had thousands of clients. Like that is like 13,197 total clients. That's really high density. For me, high density, like the stuff that I do is typically, I've done events, but they're small events, and small by where I mean like over 100 people.
Even a classroom could be considered.
A classroom could be a high density. I've had classrooms, lecture halls, where you can fit a couple hundred students in there, and each student has 2 devices. So if you've got 200 students times 2, that's a lot of devices. So that's high density right there. And they will use both.
Yeah. So for me, like my threshold, like to answer the question specifically, if I know that, the number of devices I'm expecting will be more than what one AP can handle, then I consider that area high density, and I start to look at the capacity planning a little bit more, with a little bit more attention, because I know I will need more than one access point, so it requires a little bit more planning.
Yeah,
that's my personal threshold.
Okay.
And then in Ekahau, that would require creating a different area, and then defining my devices and all of that. So that's what I do, and then doing that, I can also document it in the Ekahau project, and I can export that in my report.
Cool.
Gurpreet, if you want to.
No, those are perfect things. I think, those I probably would do the same, as I said, like airtime utilization, as you guys said already. So that's probably the key, I think, right? So, and then in Ekahau, I think you have different areas and stuff. That's pretty handy. So yeah, that's exactly what we do.
Next question is, when you want to design for a new building and customer has no idea about capacity requirements, what would you consider best guess for capacity?
If you have to guess capacity, I would recommend using Andrew Vonage's capacity planner.
Yeah.
Because you can start punching in some rough numbers there where you've got devices. Oh, thanks. I got a cup of coffee here. You can punch in general numbers, like how many clients, how many APs, how much, it'll basically tell you what type of traffic, how many are associated, how many would be in the background. Like, it's a really good Excel sheet. I was using that for a long time in the beginning. Sometimes I do still use it if I just need to give a rough estimate. You still got to validate this somehow, right, with your design, because it just gives you raw numbers. Yeah. But if you just plug that number into your design, you still got to, plan the channels, the transmit power and all that. And so that would be my best guess for capacity, but you still got to ask those questions of whoever you're working with is who are the people that are going to be coming into this environment? How many, what type of devices do you expect? And in my case, it's always a BYOD environment. So I never know. Yeah. So I try to plan for the worst case, which would be at least a cell phone. Or if I know that people are going to be bringing in laptops, then I design for laptops in mind, that kind of thing.
So I'll tell you what I do. So just assuming the customer has no idea, so it's not a controlled environment where they control the devices. If the customer has no idea, first I ask them, do you have any network monitoring systems? If they say yes, I'm like, okay, let's go and see what you currently have in your network. And then you can start to break down the type of devices they have on the network and start from there. And then you tell them, okay, look, this is what you have. This is a client mix you have today. Are you expecting it to change a little bit, or are you expecting it to be just following the trend of Wi-Fi devices, coming up in the future? And then based on that, you can create your own customized client mix for that customer, and then you can start from there. If they have no idea, if they don't have any NMS, what I do is I have a client mix that I use. It's right here. Maybe I will send it to you guys. And I just use a client mix that I created based on my experience and what I've seen, and I use that for my capacity. So the client mix, just to tell you guys, it's I based my capacity study on having 5% of a 3-streams laptop, AC laptops, 70% of 2-stream AC devices. So that could be, these ones are the most common devices we see nowadays. So that could be smartphones, tablets, laptops. Then I plan for 5% of 2.4 only 2x2 laptops. Then 15% of AC 1-stream device, and then 5% of 2.4 only 1-stream device. And I use that client mix to do my capacity planning. Now you have to understand that different environment would bring different client mix,
and also like different countries.
Yes. Yeah. So like I know in the stadium, for instance, when you do Wi-Fi for a stadium, it's a BYOD environment, but you know that people will not come in with their laptops.
Yeah.
They're going to come with their smartphone that they update every, in the US, they like to say every 1 to 2 years. Yeah. For me, my reality is more every 2 to 3 years. In other country might be, 3 or 4 years. So you have to look at, what type of Wi-Fi technology we've had in the past 3-4 years and try to base. So you might see a lot of 5 gigahertz capable client devices.
Yeah.
But if you go to, university, you can have students bring the laptop that they had, their very first laptop when they were teenage, and they're still 2.4, or even like,
if you go into a dorm, you'll see 2.4 only speakers, or the wireless consoles that are the game consoles, which are, could be older consoles and 2.4 only. So you really get a mix, but you really need to look at if you have a network management system that'll tell you what kind of devices you have on your network and what that distribution is. You've got a
good starting point. Yeah.
So one of the questions there, why use external down tilt patch antennas when in Ekahau the heat map show the internal and external patterns to be virtually the same?
That's interesting.
From the top down, looking down, they look the same.
Yeah. In 2D.
You've got to look at it also vertically, because that's one of the reasons why I use a down tilt, is because it'll focus it more vertically downwards versus horizontally. So if you start looking in Ekahau, start looking at individual APs and their patterns versus the whole 5 gigahertz or the whole both the whole spectrum. Look at individual APs and you can see what the footprint is.
Yeah.
The predictive. I mean, I don't really get to see. I don't really see 100% on a predictive to a validation, but you can kind of see what that heat map looks like for that antenna.
Yeah, and something that I'm very careful with in Ekahau is external antennas and antennas that have a different pattern, especially like any antenna that's not omni, right?
Yeah.
So I'm very careful because, like we said, Ekahau doesn't take into account diffraction, reflection. That's something you can have tons on in a warehouse environment. So if you go and do an AP on a stick, you will realize that the measurements you get from the AP on a stick is not really exactly what the model is giving you. And it's going to be, for me, it's important to do AP on a stick whenever I use external antennas, because I really want to see like the real signal propagation, including the different reflection, diffraction, and so on. And so what you see in Ekahau might not really be the real life. That's my point, right? Yeah. So even if it looks like the exact same in Ekahau, when you go on site and you measure it for yourself, when you use a down tilt only patch antenna, or if you use a directional patch antenna, you will realize that it will not be the same. Second of all, the antenna is used to send a signal, right? But it's also used to listen to a signal. Yeah. So because of the directionality of the antenna, when you use a down tilt omni, when you use a directional antenna, the antenna will not listen to any noise that you don't want to hear about, right? So this will help you minimize a little bit the noise, minimize the CCI, and plus, because of the gain, that's something that's very important. The gain, you have to look at the gain, because the gain will help the antenna to pick up the signals coming from the client devices. So in an environment where, it's a warehouse with high ceilings, the gain will really help you to make sure that the antenna is focusing on the signals coming from the client devices that are on the floor, and then use that gain to better listen to those guys and better understand the frame that they're sending. So you're going to allow your clients to send with better modulation techniques, higher data rates, higher SNR. So it's going to help the uplink as well. Yeah. So you have to think about the bigger picture. Don't just look at what Ekahau is giving you in terms of, like Rowell said, like 2D signal propagation. You have to think about the uplink, downlink communication between the clients and the antennas, and also look at the elevation aspect of it.
Because when you're using built internal omnidirectional antennas and you're putting it at such a high elevation, like 30 feet, if you increase that transmit power, you're basically not really extending that signal farther. It kind of squishes the signal. And so the signal looks really great up there, 30 feet up. And when you've got dozens of those APs up there, they hear each other really well. And so if you're using something like RRM, then you're going to end up having these APs automatically power down their radios. And so that's why I like to use a down tilt omnis as well, because it still shapes that signal, and I'm not getting too much of that omnidirectional nature at the ceiling level. But I use these when I get above like 20 feet.
Yeah. Yeah, I think one more technique that I remember François taught me once was you can just import like a blank page, like a white, and then you put your AP on it, and then you can look at the vertical as well as the horizontal plane to see how that looks like, just to give you an idea. Yeah. But as you mentioned earlier, like AP on a stick is still very important in those areas for sure.
And be sure to check the data sheet with the pattern and Ekahau. Yeah. Sometimes they don't match, and that's usually between communications with like Ekahau and the vendors. And I've had that come up twice where I look at it and I go, the pattern doesn't look quite right. Yeah. And so I'll look at the data sheet and it just doesn't match. And you just got to put in a ticket and say, hey, can you work with this vendor to get the right data sheet so the pattern looks correct? Otherwise, your design is going to be completely off.
Yeah. All right. I think we covered this one.
Yeah. It's down.
Sorry. When you're here. Oh, so I
had it. So this is my example with the down tilt omnis. And so I kind of looked at the signal strength virtualization statistics to actually see the difference in the signal. And so I think if you go to the next one, it shows a down tilt. So yeah.
So this one is a down tilt?
Yeah. The second one, that's the omnidirectional. So this is an MR42.
Okay.
That's the MR42E with the down tilt omni. And that's just a predictive.
Yeah.
So you can see like the signal is stronger. The distribution goes to the stronger side.
Because the down tilt just focuses the energy downwards. Yeah. Which is what you want.
All right. So this is an interesting question that we got. How do you prevent Wi-Fi and Bluetooth interference?
Yeah, the quick answer is you don't.
Yeah.
But the beauty of it is Bluetooth is an amazing technology. Like if you look at Bluetooth a little bit more in detail, especially the newer version of Bluetooth, is Bluetooth will dance around Wi-Fi. Mm-hmm. If you look at the spectrum, Bluetooth is a frequency hopping technology, so it doesn't transmit on one fixed channel just like Wi-Fi does, right? It just hops around in the 2.4 frequency band, and it's going to look at where the frequency is free, and where the frequency is free, just going to hop around. And even if you have Wi-Fi communication, it's going to hop around the Wi-Fi communications. Maybe one day we can show you that's a demo you can do with a Sidekick. Yeah. You take a Bluetooth speaker, you start a music, and then you start changing channels for your Wi-Fi, and you will see the Bluetooth will just go wherever you don't have any Wi-Fi.
Yeah, it kind of covers the whole 2.4 spectrum, and it depends what kind of device it is. So you're talking about your wireless mice, your headphones, speakers, like all sorts of stuff. So if I see Bluetooth, I kind of just design with it in mind. Yeah. And you let whoever you need to know that there's a Bluetooth here, and maybe you should focus your devices to join 5 gigahertz instead. if Bluetooth is actually causing an interference in your environment.
The second thing is Bluetooth is a very narrow band transmission. So even if it transmits on top of your Wi-Fi channel, only a very subset of your Wi-Fi channel will be impacted. And Wi-Fi has this error coding mechanism that allows you to recover some bits, even if you lose them during the transmission. So the error coding will allow you to recreate the sequence. That's why if you use your Bluetooth mouse all day long next to your computer and you connect it to 2.4, you're never going to see any impact on the user experience because Wi-Fi will recover the bits. The only issue you're going to have is if you have a lot of Bluetooth devices and you start to hop,
like a call center, they're all on their wireless.
Yeah, devices. And then what will happen is this will increase the noise. So you will reduce your SNR for Wi-Fi communication. So Wi-Fi will still works. It's just that your noise will be higher. You won't get as a high of SNR. Maybe this will impact the modulation technique you use for Wi-Fi transmissions, but this will work. Last thing I want to mention here, Wi-Fi will never interfere with Bluetooth. Okay, even if you put, and I do that demo when I teach EKH, when we talk about spectrum analysis. It's awesome, and I got that demo from a Fernie. So you put a Bluetooth speaker, you start music, and then after that you start introducing different interference on 2.4. The music will never stop. Even if you have Wi-Fi traffic on the 3 channels, 1, 6, 11, the Bluetooth music will always go on. Wi-Fi will never interfere with Bluetooth. The only way we can stop the Bluetooth communications is by using like a wideband generator device, right? That would just generate a signal on the whole 2.4 frequency band.
Raise the noise.
Yeah, and then the Bluetooth will stop. But that's the only way you stop Bluetooth. So
that's how you stop.
If you have customers coming to you and they're like, I think we're having this Bluetooth system that interferes with our Wi-Fi, the answer is always no. Like technically speaking, it's not possible. Something else is happening. If your Bluetooth is not working, it's something else happening on the Bluetooth application or Bluetooth, hardware devices.
Yeah, my solution would be use 5 gigahertz.
Yeah, or Zigbee.
Or Zigbee. All right, so we're going to open it up to any questions if you want to put it in the chat room. We do have one question from Gia. How about RTLS, which requires excessive amounts of APs for design? Have you done? I haven't personally done RTLS, so I don't think I'm qualified to answer.
No, RTLS, no.
You did the Bluetooth location, yeah.
Yes.
So RTLS, yeah, it requires. So first, the design for RTLS is a little bit different because the location of your access points will be important. You will be using the location of the access points to locate your devices. So the location of the access points will be important. And usually what you try to do is you try to define the perimeter using access points. You create like a big triangle, a big rectangular on the outskirt of the area you want to cover, and then you fill in the blank with the access points to make sure you meet your design requirements. So you start, I guess, from the location standpoint, and after that you look at your RF requirements to try to make it work. I don't know if I'm answering the questions because I think we missed when you said how about RTLS. I'm not sure what.
I think that came in from designing for when we were on a
capacity.
Yeah. Or high density. It was one of the previous slides.
I don't think RTLS system will generate a lot of traffic on the Wi-Fi. So I don't know if it's if it's a high density deployment. I don't know. You will definitely have more access points, so you'll be able to support more traffic. But you could leverage that for other things than RTLS.
All right, so we have another question where, so I've seen wideband 2.4 interference that has 100% duty cycle. For just a moment, it blinks on and off in 1 second or 2 seconds. How could I go about finding the source?
Oh.
It doesn't stay on long enough and EKH spectrum sees the blip. Well, that's a hard one.
Yeah.
Hopefully it's not random. So
yeah. Yeah, hopefully it's not random, so you can actually see the blip once in a while. So finding the source of an interference is quite challenging, right?
Well, if he sees it in EKH, what I would do is go to where you see it the strongest, and then I learned this from MetaGeek. using their channelizer with the directional antenna.
Yeah.
So I've used this before, and wherever you find it the strongest, you're going to want to take that square area and cut it into a quadrant. You start on one quadrant and you try to work your way towards the middle. So you're going to have to slowly take out a quadrant and say, okay, the signal's not in this area.
Yeah.
Let me go on the other side.
Yeah.
And then you get closer and closer as you start removing areas where the interference doesn't exist. And it did take me a long time. I think it took me about, depends how big your area is. It took me about 4 hours to find one source of interference that was a bad device, but I ended up finding it. And it's best to use a directional antenna for this, because if the Sidekick, unfortunately, is going to be an omnidirectional receiver.
Yeah.
So I used the channelizer with the directional antenna. Yeah. And so that's what I used to find that.
So that's funny, because we had the exact same discussion when I attended the ACAT troubleshoot class with Keith and the other guys and Jerry. And so Keith had the same technique. Mm-hmm. And I think we can do the same, but in a triangle fashion.
Okay.
So what you do is, so what you do is you do the exact same thing. You look at you take the floor plan and you take 3 measurements. You create a big triangle, mm-hmm. and then you only keep the 2 strongest. And then you take another measurements that's inside that triangle. And then from that new measurements, you only keep the 2 strongest. And then little by little, you refine your triangle until you hit the source.
That middle point.
The middle point where the signal is the strongest. And then after, what I do is, what I like to say is, and I can even actually do it, you can change your hat. And you can turn your Wi-Fi engineer hat to your investigator hat, and you can start asking a lot of questions. And I ask a lot of questions. What type of devices they have? Do they have security? Do they have voice? Do they have conferencing? Do they have, you start to ask questions to your customers, and then at one point, someone's going to say, hey, I think we did that one day, or we installed this, and then you're going to be able to refine. And because sometimes you will arrive at the location where the signal is the strongest, and you're like,
you just need to start unplugging
it's like, what do I do now? I don't see anything, right? So you have to ask questions and find out. One day I was doing some troubleshooting in France in a warehouse, and I could see some interference, and I pinpoint the location. It was like in the conference room, mm-hmm. and I didn't know, what that source was. And so I called my friend Cedric, and I'm like, do you have an idea what it could be? It's like, maybe it's like a security system or a motion detection system. I've seen them. And then I go back to the security guard, and he's like, oh yeah, we used to have this old system. And he's like, let me show you. And then he goes back in the meeting room, and sure enough, in the corner, you had this motion sensor that has like a directional. On 2.4.
Interesting.
And he's like, and then I'm like, okay, do you think we can turn it up to make sure it's exactly what I'm seeing? He's like, oh, we don't even use it anymore. It took it and plug it like that. And sure enough, the spectrum was free again. So it's not easy.
What tool did you use for that?
To detect the interference?
Okay. So you used the Sidekick?
I used at that time I didn't have the Sidekick, so I used the
USB adapters.
Yeah, the DBX.
Okay.
And in the warehouse, I could barely see but
that's where you need that directionality. So you could use the channelizer, the DBX with the directional antenna. You could use a Cisco AP with clean air and a directional antenna.
Yeah.
Or you could use an AirCheck G2 with that little antenna. That'll work. I've used that as well to find. That does even more than just finding like interference. Like I find a source, rogue APs, that kind of thing. All right.
We have another question.
I answered his one question. So Gio put in another question. When designing, how do you consider designing such that hidden nodes are very minimal or non-existent, given that 802.11n or AC doesn't really use RTS CTS to reserve nav duration? I only see RTS sent from client data and block acknowledgements.
Okay, so to avoid that, I use lower transmit power on the APs. Make sure you don't have too much mismatch between the transmit power that your client supports and the transmit powers of your APs. And then after that, what you can also do is disable the lower data rate, so you can, reduce the cell size of your.
Basically, try to get a device to roam.
Yeah,
to
basically,
a better AP.
They get the device to room to a better AP, so they never get to a point where you get the hidden node issues and two clients can't hear each other.
Yeah, so that requires one, absolutely having good coverage.
Yeah.
And then two, utilizing attenuation from your environment. And then three, optimizing the configuration itself where you increase data rate, get rid of the lower data rates to try to get a device to join to another AP or a better AP. Yeah. And also lower transmit power so that footprint of the AP is not so large.
Yeah.
The transmit power. And I do that as well as I lower the transmit power, but not so much that it's lower than an actual device that's like your phones. Like you want because then you'll reduce your coverage if you do that. So that's where a lot of the validation still comes in.
So the answer is don't use the default values.
Yeah,
default configurations.
Tune it.
All right, let's move on. We still have a few questions, right?
All right. We'll try to go through some of these faster. How much margin does my design have? What can I expect from my WLAN? So this is like a loaded question. And I added in here to throw you off.
Okay, perfect.
Since I did the slides.
So for me, I look at this question and it's a personal question to me, because I used to have the exact same question when I started doing Wi-Fi design. And it's like, am I doing a good job? You don't really know, right? And this is kind of like, it's like anything, you will build your confidence, doing more and more Wi-Fi design. So as you do more and more Wi-Fi design, you start to see that your work is paying off, your work is working well, and you start to be more and more confident, and you start to know that, it's going to work.
Yeah, you get more experience doing it, and then you understand how certain environments work.
Exactly. Yeah, you understand that, and so you'll become more and more confident. So you will never know 100% what to expect from your design, right? But you'll be confident that it will support what the customer wants. And in order to how much margin do you have, that's a question I have to return to you guys. Like, how much margin are you willing to accept?
That's basically risk.
Yeah.
So how much risk are you willing to take in by putting in a design that may or may not meet the requirements? So this is where a lot of the planning comes in. So that way you reduce that margin where you actually have a point of absolute certainty, right? You have some sort of certainty that it's going to work. And that's where you get your expectations. And I mean, there's been sometimes where I go, I actually don't know if this is going to work very well, because then maybe I haven't done the validation yet, but they already started using the wireless network. And then they start, like, I've had clients call me and go, hey, we're having issues. And I go, I didn't do the validation yet.
Yeah.
But then it's because you just need to tune it. And so that's where my margin is. It's based on how I design. And a lot of times I design on the minimum transmit power I can use, the absolute minimum, with the ability to turn it up a little bit based on how I've seen the environment previously and how I've done it before. Yeah. So you kind of have to know like how the environment, how people are going to use the wireless network, what's in that environment. And that's where I ask a lot of questions like, hey, how are you going to use wireless? Can you show me how people, like, can I talk to some of the people here and so I can see what they're doing?
I call my wife.
Yeah.
That's cellular network.
And so like the question of what can I expect from my wireless network?
So I guess one thing that's very important is validation, right? Yes. So you mentioned, sometimes they have problems, but you haven't validated the network. For me, like for my projects, like if my customer tells me I don't want you to validate the design of the installation, I tell them, I don't want to work on this project, because validation is very important. That's where you can catch all these little tweaks and things that you could adjust. And that's where you make sure that, you deliver what the customer expects. And you can actually take that time, the validation time, to validate the design, validate the Wi-Fi with the customer, And then the customer, believe me, something is not working, they're going to let you know.
Mm-hmm.
All right. And if they let you know when you validate the network, that's like the perfect timing, because you can fix it before the network goes live. And after that, everyone's happy and the network is running fine, and you will never get that call, at 2 a.m. on a Saturday, production went down, Wi-Fi sucks. When are you coming to fix it?
You start questioning yourself.
Yeah. So
I mean, the perfect example is when I told you a couple of days ago when I did that validation.
Yeah.
We turned on 802.11r because the devices, the data sheet says it supports it. Now it's one thing to look at the device and say, hey, it supports it, let me turn it on.
Yeah.
But you got to test it, right? And so this is where this validation part comes in, where I was using the actual device and the application on the device, but we learned that the application itself did not like the roaming for whatever reason. And so we turned 802.11r off and everything was better.
Yeah, magic.
So those were that was my expectation, was it was going to work better roaming. But in the validation process, I learned it actually doesn't want that. It wants to just turn off 802.11r, and because of, again, the way the application works.
Yeah, I think the biggest fact is it's very resilient, right? The Wi-Fi always works, doesn't matter what.
Yeah.
So if it works, doesn't mean it's optimized.
Yeah,
right?
exactly.
So that's the key takeaway.
That's the thing. It'll work. Just will it work well enough? All right, the next question. When designing for voice over Wi-Fi, what strategies have worked for you to make sure voice traffic gets marked at WMM6? So this is more of a QoS question.
Yeah.
And the way I'm going to answer it is it needs to be tagged through the whole network.
Yeah.
It's one thing to mark it on your wireless your system, but it's got to be on your switches throughout the whole network. And then you also cannot control it once it gets out into the internet. So the clients I work with, they like using the cloud-based voice applications. So there's, and in those networks, there's only one hop. There's only one switch and then the firewall. And after that, it's, that's the wild, wild west. So once it gets out to the internet, there's really nothing you can do to ensure that it's marked throughout end to end. But in maybe a large network, you could control that and make sure you're tagging it throughout the whole network.
So to answer, the question is, what strategies have worked for you to make sure voice traffic gets marked at WMM6? So the traffic get marked at the application level. So the application that you use to generate the voice traffic, whether it's Skype or whatever, or via IP device, that application will tag the traffic. The Wi-Fi network will just make sure the tag is maintained, right? So you're actually not going to tag. I don't think you can tag, the Wi-Fi traffic. You just trust whatever the application is giving you. And what you have to do on the Wi-Fi network is to make sure that you enable WMM, enable QoS. So that the Wi-Fi can tag and trust that traffic, and then what you can do is when you can do packet capture, right? If you want to validate, you do packet capture, and then you can filter for wlan.qs.priority equals 6, and then you'll see all that voice traffic. And what you can see is you can also source the transmit address to be your client device, make sure that the device is actually sending voice traffic. And then going back to Rowell's point of, a lot of voice applications now going online, what you'll notice is that the frames transmitted by your device will be tagged as QoS6, but the frames going back to your client devices might not be tagged as with a priority of 6. They might still be QoS frames, but they might not be QoS6.
Yeah, so you bring an important point, which is to, again, validate and make sure that it is getting tagged somehow, right? So maybe from your device, ensure that the application is tagging it, and then check to see if it does get tagged coming back. And then you can kind of troubleshoot from there, right? And then there are going to be things out of your control, but there are other tools out there like Fastlane, Cisco Fastlane, that can kind of help with that, where you can whitelist some applications and they get higher priority.
That's only for iOS, right?
Only for iOS, yeah. But there's a lot of iOS devices out there.
Yeah.
You don't have one, right? No.
Yeah, I have an iPad right here.
Oh, there you go. So I mean, that's kind of, and also, I mean, yeah, getting it marked as WM6, that's kind of like what we look for.
Yeah.
It's validating that it is getting tagged at the application level.
It's usually the case.
All right. Next question. Is Cisco's default RRM transmit power threshold of -70 dBm good enough for voice grade networks? Or is -67 a better best practice?
I don't know. That's a good question. That's the type of things, like when I change these settings, I test. Because
it comes back to testing, because maybe it will work with -70. It really depends on what's happening on the network at that given time.
And it depends which voice application you're using. Are you using a Cisco VIP phone, or are you using an iPhone with FaceTime?
Yeah. So I would say I would recommend reading what the vendor's best practices, and try to design around that. Because one of the things too is when you try to get support from these vendors, they might ask this question and go, what is your RSSI? Are you getting -67 or better? And then if you're not, most likely that vendor is going to say, well, try to get a better RSSI.
Yeah.
But I actually go for -65. That's my threshold, just in general when I design.
Is that for your primary signal strength, or is that for your power threshold?
That's my primary that I go for. But for default RRM, I also don't use default RRM. I will tune it.
What?
Again, you got to look at your application and then test it. So the way you're going to test this is you're going to actually do a test call and walk around and somehow collect logs on that device to see, is the voice quality there for what you're trying to achieve at -70 dBm.
Yeah, and do those tests with your customers. Believe me, you get more out of it.
Yeah, because you're going to look at different devices. It might not be a voice grade phone that you put up to your ear. It could be like Vocera that they put around their neck.
Yeah.
It could be something that's on their belt. So you got to actually test those scenarios, because your head has a different attenuation level than your chest and your waist. So you're going to, and that's different for every single person. So you're going to have to test those out.
Rowell, that's your slide.
That's my slide. I didn't actually edit that. Have you run into interference with lighting such as halogen or any other type?
Yeah, so this one, I've run into one of these interference once. So what can happen is, it's called electromagnetic interference, or EMI. I researched it this morning, so I could get the exact name. So what happened is you can actually, like from the fluorescence lights or from some of the ballast used for lightings, you can actually get electromagnetic energy that bleeds out and then come and interfere with Wi-Fi waves. These type of interference don't really happen anymore with LED if you have LED lightnings. So that's a good thing for us, because I think we'll see less and less, but it does comes from fluorescence and some ballast. And what's hard is that you will only see it if the light is on, right? So I was working for this customer, and then they were telling me, okay, I was service provider, and they told me, in this specific area or neighborhood, we're having issues on the Wi-Fi. Wi-Fi doesn't work on 2.4, and we don't really know why. So I was like, okay, let's go over there and do a spectrum analysis. We went on site during the day to do a spectrum analysis. Of course, during the day, no one has the lights on, so everything was good. And then they come back and they say, it doesn't work. And then so we start asking questions. At one point, we finally figured out that it only doesn't work when the light is on. And then that's then like, okay, so let's try and having the light on. And then you can see in that specific block, it's like townhouses that were built by the same real estate company, and then they hired the contractor, the electrical contractor to sell electricity, and then they use specific ballast that would interfere with Wi-Fi, and the ballast is usually located right next to the lamp, and that will generate some interference. So yes, it happens. Not very often though.
Yeah, I actually don't see it in the Bay Area, but they're always doing new construction, so a lot of sites get remodeled, and then they'll put new lighting in. It's usually LED.
LED is really good for that. It also consumes less energy, so makes sense.
Right. So if you have any questions, again, go ahead and put it in the chat, but we'll keep moving on because we got more. See, I didn't edit the template slide, but what are the best practices for post-appointment validation? So don't mind the text because I didn't edit that, but the best practice is to do one. Do a validation. It's good. Do a validation survey. Make sure it's accurate where you're walking exactly on the floor plan, and also scale the floor plan. So you want to make sure you measure out. I like to measure out like the longest wall and make sure I get that in there. Otherwise, your math from the application will be incorrect because there are levers in Ekahau, for example, in propagating signal for areas that you didn't walk. Like the exact.
It will use the free space pass loss, which is based on distance. So if you don't scale properly, you get more measurements. Best practice: use a device that your client is using. Right.
That is the ultimate test.
Yeah, that's the ultimate test. Do some application testing. The best would be to just watch the customer use the device because they'll know how to use it. They'll use it exactly the same way when the network goes live. So just watch them or ask them to show you how to use it, to test it, and then do the application testing. Some devices, sometimes they'll let you see the signal strength, where you can just take one, ask to borrow one, just walk around, validate the signal strength from that device, not from the Sidekick. We all know Sidekick will see the signal really
Go ahead
well.
and compare the Sidekick to whatever the device is seeing, and you'll see a huge difference in the receive sensitivity. And that's what I did this past Saturday. As I did a validation, everything looked really good on my end. You know, seeing
green, everything was green.
There was green in there, But we tested the device, and I actually took a scanner in the warehouse, and I was just scanning things. I walked down every single aisle because I wanted to make sure. I was only there for 5 hours. It's like, we're going to make sure this works. So I scanned everything because that application went and talked to a database that was not on site.
Okay.
And so I wanted to make sure there was nothing wrong with the wireless network that would prevent it from. So that was my so I did do a post-validation survey, but I also did an actual test of validation with the device that they use, which is mission critical. All right. What is the best practice to make a capacity plan? So this relates to the other question with the high density. So what we typically see is high density and high capacity. But sometimes you will get scenarios where maybe it's low density but high capacity because of the application usage. And generally nowadays, I'm using the Ekahau capacity planner.
Yeah, I like the Andrew Van Ash.
I use both.
Okay. So I tell you why I like the Andrew Van Ash tool is because it's more detailed. It's a little bit more thorough. So maybe we'll put a link, or we'll give you the link, guys. But if you go to revolutionwifi.net, you'll see something called Capacity Planner. You can download it. It's pretty much an Excel sheet, and from there you can do capacity planning. And I like the tool because it's very thorough. You can detail a lot of things related to your infrastructure. And it's in Ekahau. I also input the information in Ekahau, but for me, Ekahau is more for documentation purposes. I do like to see the airtime visualization. It's nice. You can do it, area per area. If you use Andrew's tool, you have to do different capacity study per area. So it's going to be a little bit more time consuming.
But it's pretty accurate. And if you look at the tabs from his Excel sheet, like there's a lot of detail that went into it, like with the types of application. You can put in your own application as well. Yeah. If you've got a custom application, you could put that in there and then do a capacity plan based on that. And then I guess to answer the question, the best practices, it would be to, talk to the customer to understand exactly what they want to do. And based on that, you can define the capacity requirements. What I like to do is when I do my walkthrough, like to gather the requirements the first time I go on site, if I ever get to go on site, is I like to go in each room. I like to ask the customer, how many people are you expecting in this room? How many devices are you expecting? And so I can use all of these information to feed into my capacity planning to do the capacity planning. Cool. Yeah.
Oh, and also one of the best practices is look at the client devices and study their Wi-Fi capabilities.
Yeah.
So we didn't talk about that a lot, but there are some websites that you can use to study the Wi-Fi capabilities of your client devices, so you know exactly how they will perform on your Wi-Fi.
What are the steps to make a Wi-Fi design? Don't mind.
The black and
Why did I not edit this? So only look at the black column. My apologies, guys. But the most important thing is you have to gather requirements. It has nothing to do with the color of milk and the version network. This is what happens when I start doing this, François, and then I went and traveled on Saturday, and then I'm traveling here.
Don't worry too much. We appreciate you.
But so my steps are gather requirements. You're going to do a lot more talking and asking. Actually, it's the other way around. You're going to do a lot more listening after you ask the questions, because you're going to want to understand what the client is using in their environment, what types of devices, what are their critical applications, what are the non-critical applications that people are using, because I tried to design that in mind as well, where I don't know about you, but I see people who actually watch YouTube videos in the background over wireless.
Like music?
Music. They'll just keep it playing in the background. And this is while other people in the same room are doing Zoom meetings over wireless. And then they say, hey, it's kind of slow. Yeah.
So a question for you, Rowell. In your studio and dome, I'm always wondering, what's a critical application? Is online gaming considered a critical application? No.
I mean, we accommodate it. We go.
If you ask the students, if
you ask the students, they'll say, music and games. But sometimes a lot of students have to do some sort of online test, but they do it in their dorms.
So that would be considered critical.
Yeah. So we try to at least make design for that sort of capacity.
Okay.
But typically, a dorm will have an AP in its own room.
So to go back to the question, so gather the requirements. When I gather the requirements, I like to look at two different families, I guess, of requirements. First, anything related to the building, the floor plans, the wall, the ceiling height, the scale, and blah, blah, blah. Aesthetics requirements, we have that right too. And then in the second family, anything related to the Wi-Fi, the future Wi-Fi network, client devices, application, AP to be used, a number of SSIDs. Yeah, they're joining the party. And then I take all of that, I do the design, and then when you've done the design, at the end of the design, you should know exactly how many APs you'll use, which AP, which antenna, and then you can create a detailed report that you can send to your customer, and then from that point, the customer will install the access points, and you can move on.
You made an important point too, which is design on the AP and antennas that you are going to use. Don't use another vendor's AP, another vendor's antenna, or the generic antenna, because they all have different propagation patterns. They're all very different properties as well. And if you're designing it on, for example, an Aruba AP, but then you deploy a Cisco, you may see things that you didn't plan on. You just didn't accommodate.
Even two different models of the same vendor. Sometimes
if you're going to use if you're using a 4800 to your Cisco 4800 to your design, but then you deploy a 1800, don't do it. Will non-Wi-Fi 6 clients see much, if any, performance enhancements with Wi-Fi 6 APs? I said yes.
Yes. Okay. All right.
Right. No explanation.
I think from that point we have Wi-Fi 6 questions. Do you want to keep them for a second?
I removed a lot of them. So we will have a separate Wi-Fi 6 session, but we'll touch upon a little bit here. The reason why I say yes to this is because the new APs will have newer hardware, better antennas. Once you have Wi-Fi 6 clients joining, they'll be on an efficient. They'll use the efficient protocol, Wi-Fi 6 protocol, which will make it better even for the non-Wi-Fi 6 clients.
And if you look at how the client devices use the airtime available, to them right now, they divide all the. Are you scared of it?
Yeah, I hate spiders. There's a spider on the floor, and I hate spiders, but I don't want to kill it.
So right now they all share the airtime one at a time. Now, knowing that some of the Wi-Fi devices would be, better utilizing that airtime, this would free up more airtime for the non-Wi-Fi 6 devices. So that's another way of thinking as well.
Exactly.
That Wi-Fi 6 clients will improve a little bit the life for the other guys.
But again, validated.
Yeah.
What consideration should be made for Wi-Fi 6 and 2.4 devices? Will Wi-Fi 6 devices and 2.4 gigahertz be less susceptible to interference? And again, default slide. I didn't change the text, but
I don't think so.
But I mean, what consideration should you make, right? So hopefully Wi-Fi 6 devices will be on 5 gigahertz.
Well, I'm thinking
they have 2.4 radios.
Yeah. What I'm thinking about is, the idea behind Wi-Fi 6, and when you look at the documentation from, the IEEE or Wi-Fi Alliance, they're talking about different type of devices coming up to market, IoT devices, the VR headsets, and all these devices might not have the same requirements from the Wi-Fi network, right? VR headsets need a lot of bandwidth, low latency connections. IoT devices might not need a lot of bandwidth, and they're not going to generate. They want to be able to sleep more often. So in the whole Wi-Fi 6 improvements, they try to accommodate different things for different type of client devices. And I think that the idea of bringing back Wi-Fi 6 on 2.4 was more to accommodate IoT devices, where the goal would be to just transmit once in a while, once a day, once a minute, once an hour, and those will not generate a lot of traffic on the frequency, 2.4 frequency. So even if the 2.4 frequency is busy, I think it will not impact those IoT low bandwidth type of devices.
And I think that's what we're expecting to see. But again, it's still too early to talk any more about Wi-Fi 6 because we haven't seen it in the wild with a mixed environment. So a lot of these efficiencies and improvements may be just seen with only Wi-Fi 6 devices. We don't know how the non-Wi-Fi 6 devices will interact on a mixed environment. All right. So we'll pick a question from the chat. We have one question. Do you trust Ecohouse building compositions when stacking floors, heavy floor versus standard office, etc., as it relates to AP stacking vertically? Do you test attenuation between floors to validate?
Yes.
Yes.
So in order to do that, you need to do, kind of an AP on the stick measurements where you put an AP on one floor and then you go down the lower floor and you measure the interfloor attenuation. And you want to measure that because it will impact your co-channel interference.
Yeah.
What I try to do, I try to rely on the APs I install on one given floor to give me coverage for that floor. And then when I go down, I install other APs to cover that floor as well. And I don't rely on the interflooring, bleeding signal to cover other floors, because that you will provide lower SNR to your clients, and you will introduce what I call the interfloor roaming, where you have a device that roams to access points that are located on different floors. And that will generate more roaming events, and that's not optimal for your Wi-Fi performances. So, and I had a customer one day in Toronto where they installed AP every other floors. Why not, right? Wi-Fi wasn't working. So
So the short answer is no, we don't trust the default building compositions. So even when it comes to like wall types, I'm creating my own wall types based on the measurements I collected. Between floors, sometimes I don't know what's in between floors. So you do have to take those measurements. If you're able to go on site and at least with a device, I'll use maybe the lowest device, which is a phone. And I'll, with a Wi-Fi scanner app, if you can see the BSSID, I'll capture on one floor. Go down below. What signal do I see that same BSSID on the floor below or the floor above? And so I'll try to take those measurements and try to accommodate that into the design in the Ecohouse file.
Can you save custom wall types in Ecohouse? Seems to only be able to retrieve it on one project. So the wall types will be specific to one project, but what you can do is you can create your own template. And then so the way you create your own templates is you do file new, you don't import any floor plans or anything, you just create your wall objects, and then you save that file as a template, and then anytime you start a new project, you just copy paste that template, and you're starting with all of your walls. But that also, you can also include all of your requirements, project requirements, your devices types, and all of the things that will be
save everything that you end up changing when you first create a new file. And always use that file. So those changes do not carry over to like the next new file that you create. All right. Do you think 802.11ax? Yeah, there's just a couple more.
Okay, all right.
A couple more.
We're almost at the end.
Bro, we're almost done. Do you think 802.11ax cell sizes will be similar to existing 802.11ac designs?
Has nothing to do with the acceleration.
Yeah, it'll be based on how the AP and antenna is.
Yeah, the cell size will depend on the antenna pattern and gain. So it has nothing to do with the actual layer 2 technology you use.
Right.
Except if you configure data rates and stuff like that. But
I don't see early adoption actually paying off because of legacy clients in my WLAN and surrounding my WLAN. What are your thoughts? And this is about Wi-Fi 6. I don't see any big payoffs either. So maybe the question is like, should you migrate to Wi-Fi 6 now? If Wi-Fi 6 APs, if you could wait, I would wait. If you have to upgrade now and your refresh cycle is really long, like 5 years or 7 years, just upgrade now.
5 years is not a long refresh cycle. I've seen, like, especially back in Europe, I've seen companies keeping the APs for 10 years.
Yeah. So if you have to upgrade now and you have a 10-year refresh or refresh, then upgrade now. So that way when the Wi-Fi 6 clients do come, the Wi-Fi 6 clients, then you have Wi-Fi 6.
You have the infrastructure to support it. And it has to start, it's like a chicken and egg issue. You have to start at one point, and you can start at the infrastructure. And anyway, the vendors, at one point, they will not let you buy AC access points anymore, right? They want to send.
And before you even purchase Wi-Fi 6 access points, get a few for demo purposes just to test it out. And test it out with your devices, test it out with your applications to see if you're expecting the same results, because this is new hardware, new protocol, there's going to be bugs.
Yeah.
And so we have to find those bugs with all this. It's just like using any other new technology, right?
Sounds like you had some experience.
Yes. All right. So that was the last question, François.
Awesome.
Unless anyone else has any questions in the chat.
Oh, no, we answered this one.
Other than that, we kind of breezed through it. Yeah. But I only added a few Wi-Fi 6 questions in there because we're already pretty long here. We'll do another webinar just on Wi-Fi 6 because, in fact, you and I are doing a presentation at WLPC Prague on Wi-Fi 6 as we're testing out multiple APs and devices, checking it to see how it actually interacts with devices. And we're going to do some mixed environment testing. So we'll see how that goes. We just kind of wanted to do our first webinar and get it out there, get to know you guys that joined, and then we'll reshare this out. Also, there'll be a recording that we'll
put on YouTube. Probably.
Yeah, we'll put it on YouTube, and we'll also put it in audio format for the podcast.
Okay.
But if you guys have any other questions, if you have any feedback or comments on this webinar, just let us know on Twitter at ClearToSend. You can hit us up on email, hello@cleartosend.net. We appreciate Slack. All the questions. Yeah, you can hit us up on Slack if you're not on our Slack already. I think you go to cleartosend.net/join-Slack. But we appreciate all the questions coming from John and Gia and Chris. Those are really good questions, and hopefully we answer them. If we didn't answer them, just let us know, and we'll do our best to actually get to the point.
Yeah.
But other than that,
thank you guys.
Thank you for joining.
Hopefully
we appreciate it.
It was entertaining. Thank you guys.
It was for sure.
And we have Gurpreet over here on the side. You want to show yourself on the camera?
Sure. Hey guys.
All right.
Thank you guys. We appreciate it.
Thank you.
Thanks, Gia. Thanks, John. Bye.